if I asked you to calculate your pay, which I've done several times, given hours worked and pay rate, everybody would know how to do that. Okay? You'd know how to create an IPO chart. You'd know how to write the code for this. You'd know what operators to use, including the assignment operator, in this case, probably multiplication. Now, if I asked you if you worked overtime, how would you write a program that took that into play? Right now, you don't know how to do that. By the end of today, you will. Okay? You might also, how does overtime work? What is the scenario with working overtime? Justin? Yeah, and that's the case for what? That is exactly right for overtime. But so when do you get paid overtime? Typically, you get paid overtime if you surpass 40 hours. Now, do you get 1.5 times your pay rate for all the hours? Not me, or I don't get overtime. But that's not typically the way. When do you get for which hours do you get paid overtime? Tyler? The hours exceeding 40. So we're going to need to learn how to write a program to accommodate that, okay? So the other scenario might be that if you work over 60, you get double overtime. Is anybody working a job where they have the opportunity to work double overtime? Okay. So some people have it so that between 40 and 60 is time and a half, and the over 60 is double overtime. So we're also going to learn how to write the solution for a problem like that. Now, one thing that we're going to find is that the IPOs, I know you love them, but the IPOs are going to be less useful when we get to problems that require decisions. So we're going to sort of phase those out. They were just there initially to help you solve the problems, to help you get from that problem, staring at the problem, and then not being sure how to write the solution. But with the if-else, they're a lot less helpful, okay? As the problems get more complex, the IPOs are a lot less helpful. Okay, so let's review the operators that we talked about that are going to be particularly appropriate when we talk about selection. Okay, the less than and the less than or equals, and the greater than and the greater than or equals are of course very familiar to us. And we choose the less than if we only want the expression to be true for values that are less than something. If we want to also, sometimes the word inclusive is used. If we want to include the value, then we would use the less than or equals. If we're only interested in values that are greater than, then we would use the greater than, and if we want to include the value, be greater than or equals to. Just note on the computer these are two symbols as opposed to math where you use one symbol. In the computer you actually have to type two of them. Okay? We also looked at this operator, which differs from the operator we looked at last week. Okay, so let's review. Okay, what is this operator that is circled right here? What is it? Test for equality. And so if I have two operands, for example, x and 3, this checks to see if x is equal, has the same value as 3. And what is the result of this expression? What would the possible result be, Tyler? True or false? So this expression is going to have a true or false result. Now, what about if I have, can you guys see on the, no, I always get blindsided there. Can you see now? Okay, so if I use this operator, what do we call that operator? Assignment. What happens in that situation? 3 gets stored at x. So these are extremely different. But this is actually considered one of the criticisms of C++ and Java. The fact these operators look so close to each other, it's easy to make a mistake. And it's not a syntax error. Most likely you will not get a syntax error if you mistakenly use these operators. It'll just be some sort of silent error that'll be hard to find. So again, this assigns x the value 3 from right to left. 3 goes into the memory location called x. And this checks to see if the memory location x has the value 3 and returns a true or false. So in the if-else, which we're going to talk about shortly, we're going to be using the test for equality. We're going to be using this operator, not this operator. Okay? The assignment operator is typically used when we use operations and combinations of operations, addition, subtraction, multiplications, equations type things. Okay? In the if-else, we're testing some situation, some condition, and therefore we're going to be using the test for equality. This tests to see if something is not equal to. So, for example, x not equal to 0, so that means any value besides x would be besides 0 would be true. Okay? So these are the relational operators, most of which you're familiar with. Okay? Let's take a look at these examples. So in the case of the first example, 10 greater than 2, what is the value of that expression? True, obviously, right? The first expression on this slide is true. 10 is greater than 2, so that would always be true. Now, what about the second one? I want everybody to think about the second one. A lot of times I'll put this on a quiz, and people kind of panic. But we actually can figure out the answer to the second one. I don't have it numbered. But we can actually figure out the answer to this. Why is this expression true? Tyler? Yeah, and if we actually, okay, he said, let me repeat for the mic, he said that A comes before C in the alphabet. And if we actually went and looked at that ASCII chart, we would find that A has a lesser value than C, so it is in fact true. So if A is 61 and C is 63, then 61 is less than 63, okay? So don't panic if you see a problem like that. Yes, A is less than C. It does have a lesser ASCII value. You don't have to know the values in order to know this is true. Agreed? Okay. Question, Robert? Yes, yes. And the uppercase also have the same set of, truths as well. And the uppercase A has a different value than lowercase a. And I believe uppercase A is first, less than. Because do we usually precede uppercase with lowercase in the alphabet and when we alphabetize? We could look at the chart and confirm this. But the values, again, we don't need to know the exact values. We just need to understand that they do follow each other based on alphabetical order. Okay? Okay, x not equal to y is going to be true if those two values are not equal. Of course, these are more useful. Temp greater than humidity. Num is num equal to 35. Initial not equal to q. What does the single quotes mean around the q? Character. So that means that initial is a character type. And it says is initial not equal to the ASCII value of q. Okay, what would happen if I forgot the single quotes around the q? What would the compiler do? Think it was a variable. It would think it was a variable. It would be a syntax error. If I forgot the single quotes, it would think q was a variable, and it would be a syntax error. Okay? Okay, then we have what I think are the more interesting ones, the and or the or. Now remember, in C++, use double and. Single and is actually legal in C, but it does something else. Okay, it does a bitwise and. So make sure you use the double ampersands and the double vertical bar. So remind me again what the and means. Tyler? Both must be true. Both must be true. Okay? And if we look at the truth table, the only time it's true is if they're both true. Okay? And then we had the or condition. And what's the situation on the or? Give me a 5-second summary on the or. Who wants to tell me what the or does? Whitley? One has to be true. So in any case where one of them is true, okay, they're all true. The only time an or is not true is if they're both false. Okay? And then the not, which is not used as much, but sometimes this really fits the bill, it takes whatever the current state is and negates it. So if it was true, not true is false. If it was false, not false is true. Okay, so now let's look at some of the details about this guy. Well, we're going to do that in a second. Let's first look at an example. This actually has an error in it. I'll tell you that in a second. But the very first example has a variety. Now, see, this is an interesting statement because it has a combination of relationals and logicals. Combination of relationals and logicals. So there's where we get some pretty interesting logic. Okay? So let's take a look at the first one. And what is the first one essentially? What is that first if testing for? What's the scenario on that? What is going on in the real life of this? Colin? In order to win the merit award. So in this case, the individual is eligible for this award if all three conditions are met. An and means they must all be true, true, and true. The only individuals who are going to get the merit award is one where there are 3 trues. Does that make sense? So and implies that all those conditions must be true. Does that make sense? Okay. The second condition is, remember I talked about, so this is in this case specifying a local zip code. So can somebody explain to me what this expression indicates, statement indicates? Tyler? Okay, so in this case we're allowing all 3, so the or means that if 1 is true, any one of this true, this will be true. It's not really possible that more than 1 could be true, but as soon as 1 is true, this guy will be true. Okay? Now the error is a C error. Jared? There should be another, thank you, there should be another set of parentheses around the whole thing for the first if. So that's a C syntactical error. C requires 1 large set of parens around the entire expression of the if. Okay? So that's just an error on that slide. Okay, now we're going to go into a lot of examples with these and make sure you know how to write these if-else. We haven't gotten to the if-else, but make sure you know how to write these conditionals. But I want to talk about one little trick that's the scenario with the and the or. Okay? There's something that can happen called short-circuiting an and or an or. Let's go back to the table a second. And let's take a look at the and. Is there any scenario where I could short-circuit a big, long expression in an and not necessarily have to keep evaluating? Brian? Good answer. He says if the first condition of an and is false, I can short-circuit, meaning I've got a bunch of expressions, and there's ands between them. If one of those guys is false, okay, I know for sure the final answer is false. So there is no need for me, or guess what, the compiler does the same thing, to continue evaluating once it gets a false in an and. Does that make sense? One false in an and, we know for sure the entire expression is false. Now, what if we have a true in an and? Can we short-circuit that? No, because what could come next? A false, which would make it false, okay? A true, which could make it true. So one true is not enough information to short-circuit, okay? You following me? Now, what about the or? Is there anything we could short-circuit in the or? Can we short-circuit in an or? We have a bunch of expressions. They're created by ors. Jeremy? Say that again? Okay, but try to do it on 1. So if we get 1, and it's or, let him answer. So we get 1 if it's or. If it's false, we don't know. We can't quit, right? Because it could still be. But what if it's true in an or? No, the first one. So we get the first guy. The first expression we evaluate, and we know there's or. In an and, we knew that one false, absolutely one false causes the end result to be false. Okay? In an or, if we get a false, we're not sure what the scenario could be because we could have a true following. However, if we get a true first, what's the scenario? Anytime we have a true, one true, the answer is true. Okay? So in the case of an or, we can short-circuit upon the first true. Because one true is enough to make the whole guy true. Does that make sense to everybody? Okay. So let's take a look at this example here. Oh, I have an error here. I need to fix this. I need to fix 2 of these slides. I'm writing myself a note. Which slides had the error? Let's see. I need to fix the declaration, and I need to add parens on the if-else. Declaration and short circuit. Okay, just a note to myself. Okay, so in the following scenario, if age is 25 and height is 70, can I short circuit this first expression? Take a look at this expression. Don't shout out the answer, please. Let everybody look at it. So if age is 25 and height is 70, can I short circuit when I get to this first expression in the and? Who'd like to try an answer? Teresa? Okay, and one false in an and, it's for sure false. So this expression can be short-circuited by you, meaning that if you're evaluating it, you don't need to evaluate anymore. The same thing happens with the compiler. When the compiler determines that there's enough information not to have to keep evaluating, it will not process the rest of that line. Okay? So since this is false, there's no way in an and that this can be true. It's definitely going to be false, so it stops. Short circuits that guy. Make sense? Okay. So second one, height is 70. Can we short circuit the second expression? For the same reason, 70 is greater than 60. This is an OR. Once we have one true in an OR, there's no point in going on. It's definitely going to be true. Now, if I have a combination of ands and ORs, C++ and Java have this weird rule. And has higher precedence than OR. Okay, not the same. And has higher order of operation than OR. So ands will be evaluated first.